All right, awesome. Hopefully you enjoyed that great video on how to calculate the chi-square test in your calculator. So let me just review that for those of you who might have missed it or weren't 100% clear on everything. So you can use your calculator to not only find your expected values, but to perform all the calculations to get your p-value. Okay. Now, what they didn't talk about in the video is a couple of things that are important that you need to show in your work to get full credit on the AP test. So make sure that you're following along with me so you know exactly what those are and exactly what to include on your work. So on your calculator, you're going to go to the matrix button. Hopefully you used this last year in pre-calculus, so you're not totally unfamiliar with the matrix function in your calculator. If not, it explained it pretty straightforward on YouTube. If you're still having issues, you can email me a question, or just try and find some more videos about the matrix function. Basically, go to the matrix screen, the button, and then you're going to enter in your observed data into matrix number A. So you go over, probably the trickiest thing on this is for memory that you have to go over to edit to make a new matrix. So you're going to go into matrix A, go under edit, and then you're going to type in all of your observed values. And like they said on the video, you're not going to be doing the totals. So I actually shouldn't have circled the totals on the bottom there. Got a little overzealous with my circling. So you're only going to put in the individual numbers for the categories, not the totals. So you should have if you're putting this in your calculator, you should have a 3x3 matrix with these three values from your these 9 values from your observed values in your matrix. Okay, and put in the matrix A. Then you're going to exit out of the matrix menu and go to Stat, Test, and we're going to talk a lot more about this menu, the Stat Test menu, as we're reviewing for the AP test. But for right now, we're only going to be worried about one of these, which is the chi-square test, which looks just like this. Make sure you don't hit the goodness of fit test. We're dealing with just the regular chi-squared. So goodness of fit is something different. Chi-squared is going to be the same one for independence or homogeneity. So you select that one. Make sure that you put matrix A in, hit enter, and it does all the calculations for you. It gives you your chi-squared value, which is 10.6727. Gives you your p-value, so you don't have to do anything to get that p-value. It's just 0.0305. And then for your degrees of freedom, that's going to give it to you straight on there. And the way that you calculate degrees of freedom is the formula. I put it up here on the sheet, I believe. All the way up here. It's the number of rows minus 1 times the number of columns minus 1. So we have the number of rows, 3 minus 1, which is 2, times the number of columns minus 1, which is 2. So 2 times 2 is 4, and that is going to be your degrees of freedom. But you just know how to put in your calculator. It's going to calculate it for you. Now, the three things that you're going to be looking for on the AP test are the chi-squared value, your p-value, and then your degrees of freedom. So make sure you write those down and label them in your work. All right, so now that we have our p-value, we analyze it just like any other significance test. So it didn't give us a significance level, so we're going to assume that's 0.05 since our p-value is below that. We have statistically significant evidence to reject the null hypothesis. And that second sentence, remember, we want to have that context. So we have evidence that there is a difference in music genre preference between middle, high school, and college students. That's it. That's our interpretation. Now, if you notice, since my interpretation at the end is almost identical to what my alternative hypothesis is, right? It's almost exactly verbatim, because if you take the time to really make your hypotheses good, it's going to make your interpretation a lot easier as you're going through and doing it. My alternative hypothesis is we're going to come up with our context. All right, so that's how we go ahead and do one of the tests. And then we had this part D that we're going to look at too. So it said if you had a chi-square test for homogeneity, which this is what we said it was, explain how the data could have been obtained to make a chi-square test for independence or association appropriate. So what we would have changed in this study to make it a test for independence is we take one sample. So instead of going to these 3 different schools and doing separate samples of 50, we would go and just select 150 students at random and then put them into categories: middle school, high school, and college. Notice the difference. Homogeneity is more than one sample. Okay, we had 3 different samples, one from middle school, high school, and then last from college. And then if we wanted to do an independence test, it'd have to be all from one sample. So we do a whole sample of 150 students and then categorize them based off what level of school they're in after that. So it's kind of a very slight difference. All the calculations are going to stay the same, but important to know the difference so you can identify which test you're dealing with. And again, that video, YouTube video especially, explains it really good in detail. So if you're very confused kind of after all these videos today, I'll go back and rewatch that video to help you out with it.